Hey, welcome back. Glad you're still with me. Did I startle you? No. Okay. So, as we were talking about at the end of part one, we were looking at how if there are things in a permutation that look the same as another one, we eliminated those. And really what it boils down to is if there are n number of objects and then a of them are the same, you can divide by a factorial and that will get the number of unique permutations. Okay, so this is basically our formula then. And you can divide by more than one, which we'll look at in a couple of these examples. Okay, so find the number of permutations of the letters of the word Vancouver. Okay, so first of all, number of ways of rearranging the letters in the word Vancouver. Let's look at that. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. So there's 9 factorial ways to rearrange those letters. But, and this is the sneaky part about these ones, they don't always say in the question, hey, did you notice that there's 2 V's in this word? Okay, so what you're going to have to do is always be on the lookout for things in the word or number or whatever it is that are the same. So we have 2 V's, so we're going to divide by 2 factorial to get all the situations where if you switch the V's it looks identical. And let's look at the other letters. Anything else the same? Nope, they're all unique. Okay, so 9 factorial divided by 2 factorial will give us our answer. So off to the calculator with that. And we should get 181,440 number of ways to do that, I do believe. Okay, so let's take a look at the next word, mathematical. Of course, it's math, right? So how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 letters we are going to be rearranging. So 12 factorial. And now we're going to look for the repeats. So we have 2 M's. Okay, so we're going to divide by 2 factorial. Anything else? Yes, we do have 1, 2, 3 A's, so 3 factorial. And we have 2 T's, so 2 factorial again. And let's see, what are we left with? H-E, I-C, no, we're okay now. Okay, we're going to put this in the calculator. When you do that, you have to make sure that you have brackets around your denominator because we're dividing by more than one thing. If you don't put brackets, then it would just simply be 12 factorial divided by 2 factorial, whatever that is, and then multiply that by 3 factorial, 2 factorial, which is not what you want to do. Okay, so make sure when you go off to the calculator, you got brackets around your denominator there. Okay, so you go do that, and we should end up with, whoa, what a big number. Okay, so we have 1, 9, good so far, right? 958, it's like the lottery. 400, and did you win? Yay! Okay, good. Example number 7. I know, I'm weird. Okay, Brett bought a carton containing 10 mini boxes of cereal. Alrighty, I know those mini boxes of cereal. Okay, there are 3, and there's usually no cornflakes in there. No, I'm sorry. It's all sugar stuff. Okay, there's 3 boxes of cornflakes, 2 boxes of Rice Krispies, 1 box of Cocoa Pops, 1 box of Shreddies, and the remainder are Raisin Bran. Oh yeah, there's always the ones that people don't like, right? Okay, over a 10-day period, he plans to eat the contents of 1 box each morning. Okay, so order here matters because, you know, whether he eats cornflakes or Rice Krispies on the first day matters to Brett, okay? Not to us, but to him. Okay, so how many different orders are possible if on the first morning he has Raisin Bran? So they are restricting what he's having on the first morning. So let's fall back to fundamental counting principle for a minute here. So pretend we have like 10 blanks here. Okay, on the first morning he has to have Raisin Bran. And they didn't tell us directly how many there are, so let's add these up. 3, 2, that's 5, 6, 7, so the remainder are 3 Raisin Bran. So he has 3 choices of boxes on the first morning, and then after that they didn't really say what he had to eat, so he would have 9 cereal boxes left, then 8, and you're going, oh, it just keeps going down. Okay, well once you recognize that, then let's just write that as 3 times 9 factorial. Okay, and you'd think you'd be done right now, but here's the scoop. If he grabs one box of Raisin Bran, he could have actually grabbed one of the other two and you wouldn't have known any difference. It's still Raisin Bran, right? So those situations are identical. So we need to divide by the repeats here. Okay, so we have 3 boxes of cornflakes, so 3 factorial. 2 boxes of Rice Krispie divided by also 2 factorial, and then Raisin Bran 3 factorial. Okay, so you're going to throw that in the calculator. This time you need to make sure you have brackets around both numerator and denominator. Although, actually, you could get away with not around the numerator because it's multiplying, but that's okay. Let's be consistent. All right, throw that in your calculator and let's see what you get. If you want to pause your video and do that. Okay, so we should have ended up with 15120. Okay. All right, so 15,120 possible ways. Why would you want to figure that out? Okay, example number 8. Ours is not to question why, ours is to learn this. Okay, Paul and Catherine are considering the following problem. Find the number of routes from A to B if routes must always move closer to B. Now, Paul arrived at the correct answer by tracing 10 routes on the grid. Now, he must be a visual learner, so he might have gone like this, and then went, or I can go like this, or I can go like this. And that works fine when it's a small situation, like only 6 little squares here, but he got 10 routes. Okay, Catherine developed a quicker method. She realized that traveling from A to B involves moving 3 units east, 1, 2, 3, and 2 units south, 1, 2. And the answer to the problem is the number of ways in which this can be done. Okay, and that's essentially thinking of it like a word. Okay, so 3 units east could be east, 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 and then south, south. So you might have gone east, 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 south, south, or say east and then south, and then east, east, and then south again. So really, that is a 5-letter word. You could think of it like 5-letter word. Okay, so number of ways to rearrange a 5-letter word, 5 factorial. However, you wouldn't be able to tell if these 2 e's were switched here. So we need to divide by the repeats to eliminate all the repetitions or the permutations that look the same. So we have 3 e's, so divide by 3 factorial, and 2 s's, so divide by 2 factorial. And again, just be careful with the brackets around the denominator. Off to the calculator, let's figure that out. Ding, ding, ding. Do, 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 do. Okay, so we should have gotten 10. We kind of knew that already, didn't we? Okay, so 10 different ways to get there, and so Catherine got the same thing. I would definitely use Catherine's approach on future questions, especially if there's more than 10 different routes to go to. All right, so you guys should be ready to do this assignment. Yahoo, good job. Thanks for listening, and we'll see you on lesson 4.